It is again the time of the year where the Philippines experience rain almost every day. But have you ever wondered why there is rain or how does rain forms? Of course you know how it forms. It's just water cycle. We already know that it is part of the water cycle. But why is there a water cycle? How the hell does water get into the atmosphere? Is it because of an alien technology? Or is it just kinetics? In this video, we will explore the kinetics behind the water cycle through doing experiments about the concept of heat transfer through convection and the expansion of matter as temperature rises. Also, we will investigate why it feels more comfortable to wear light-colored shirts when it is hot. But before anything else, let's define our terms. When we say heat transfer, we refer to the transit of thermal energy due to a temperature difference on a system. In our first experiment, we will look at the effect of the rise in temperature on the pressure of a system. The outcome of this experiment will partly explain the ascension of water to the atmosphere in the water cycle. This experiment uses the following common materials: a glass bottle with cup, ice cubes or tube, a glass or plastic jar, tap or bottled water, a pan, and a stove. Water is first boiled within the bottle using a stove to the point where bubbles form rapidly. The bottle was then cooled for about 10 seconds before putting the cup on and turning it over and putting it on the glass jar. The ice cube was then put on the top of the bottle and observed for a short moment before the water boils once again. The concept behind the boiling of water using ice is highly attributed to the pressure difference made by the ice. Pressure is first built up in the bottle through the first boiling of the water. When the ice was placed on the top of the bottle, it absorbed the heat on the top portion of the bottle, making a temperature gradient which effectively resulted to a vapor pressure gradient. The cooling of the vapor effectively reduced the velocity of the molecules in the vapor, which basically lowers the vapor pressure on the cooled area. This is due to the fact that pressure is due to the collision of the molecules with each other and on the wall of the container. Since vapor pressure on the top portion of the bottle is lower compared to that of the water boiled. It indicates the equilibration of the system in terms of the vapor pressure. As explained, the pressure of a system decreases with a decrease in temperature. Similar to the water cycle, an increase in the temperature means an increase in the vapor pressure of water, and hence faster movement of water molecules. Note that since our atmosphere naturally wants to be in equilibrium, there exists some amount of water in its gas phase in the atmosphere near the surface of water. An increase in temperature speeds the movement of these water molecules in the atmosphere, causing them to disperse, which results into a less dense water vapor. Then since our water vapor is now less dense, its tendency is to ascend. In the second experiment, we will try to make sense on what happens as our less dense water vapor ascends. We will look into the concept of heat transfer through convection. This experiment was derived from How the Weather Works by Michael Alabi. For this experiment, 1.5 liter bottle, scissors, food color, glue sticks, match, candle, and plastic tube were used. Equipment preparation. The bottom part of the 1.5 liter bottle was cut. The two sections served as a container of water of varying temperatures. The two sections were joined together with a tube by creating a hole for both sections where the tube can tightly fit into. The tube was then glued on both sections. It is advisable to glue it properly to ensure that leakage would be minimized or neglected. For the first setup, food color was mixed with boiling water. Boiling water and cold water were then put in the bottom section and top section respectively. Simultaneously, the tube was pinched to induce pressure for the transportation of fluid from one section to another to occur. The pinch was then released to allow the movement of fluid. For the second setup, the same procedure was conducted, but this time the cold water with food color and boiling water was allocated in the bottom and top sections respectively. As stated earlier, convection is a mode of heat transfer that requires a medium. There are several types of convection, namely natural, forced, buoyant, and granular. In this experiment, natural convection was observed. Natural convection is driven by temperature gradient, which affects density and buoyancy. For the first setup, hot water being injected into cold water, it can be observed that as the hot water rises up, it diffuses radially outwards and continued to rise up until equilibrium was attained. As for the second setup, cold water being introduced into hot water, the reverse phenomenon occurred. That is, as the cold water rose, the hot water diffused into the cold water. Then when the cold water reached the surface, it sunk. The rise and sink motion are due to the fact that higher temperature constituents are less dense than lower temperature components, as shown in the previous experiment. And in accordance with the physical law of buoyancy, the denser component must sink and the less dense constituent must rise. Meanwhile, the radial diffusion observed on the first setup showed the diffusive action of the hot water towards the cold water until a constant temperature was achieved by the system. The sinking of the cold water and the rising of the hot water can be regarded as advection. Advection is the transfer of heat through fluid motion, which in this case is induced by buoyancy. Diffusion, on the other hand, is a transfer of heat through the motion of the random motion of molecules. Together, advection and diffusion constitutes the heat transfer through convection. As explained, the movement of the colored water is due to the density difference of the hot water and the cold water. In the case of the dispersal of the hot water and the cold water, the diffusion as noticeable occurs in the radial direction, which indicates the diffusion of the hot water into the cold water. Consequently, in the condensation stage of the water cycle, as the water rises up into the atmosphere, it interacts with molecules of lower temperature. Since the tendency of the heat is to flow from higher temperature to lower temperature, the heat is diffused into the other molecules, causing the water molecule's temperature to decrease, meeting the boiling point, and condenses. Hence, our water cycle made cooler with kinetics. Moreover, in the third and last experiment, we will see if the tip that one should wear light clothes when it is hot is just a myth or is a good one. In this experiment, two 25-centavo coins were mounted separately on a black and on a white paper respectively using wax. The papers were mounted vertically in parallel with 25-centavo coins facing outwards. Lastly, a burning candle was placed in the middle. It is made sure that the papers are of the same distance from the candle. We waited until one of the 25-centavo coin fell. Concept: all things that are at temperature greater than absolute zero, negative 273 degrees Celsius, emit some form of electromagnetic radiation at various intensities. An object that is theoretically known to absorb all EM radiation falling on it is known as a black body. A black body is represented by an emissivity coefficient of 1, which represents perfect absorption of radiation. In the experiment, the black body is represented by the black construction paper. By being color black, the paper will absorb all the wavelengths of light. However, the absorption of these wavelengths is accompanied by an increase in temperature. As such, in order to attain thermal equilibrium, the black paper will emit radiation of the same amount as it has absorbed. Hence, since the surface of the black paper experienced a faster increase in temperature compared to the white paper, the wax attached it melt faster. Consequently, the coin attached to it fell first. As for the white paper, its color allows it to transmit all incoming radiation towards it. Ideally, the emissivity coefficient would be 0. As such, there would only be a slow increase in temperature for the white paper, as supported by the fact that the time it takes for the coin to fall off the ground is much higher as compared to the black paper. Though might look simple and boring, the concept behind the faster melting of the wax on black paper is a gem, which is a topic for next time. However, it just proved that wearing light clothes when it is hot is the right thing, and not just a myth. Light-colored clothes transmit less heat onto the wearer compared to the dark-colored ones. Alright, we just did 3 experiments which deals with some heat transfer phenomena. Now you know how the water cycle works, at least in kinetics, and that wearing light clothes on hot days isn't a shit idea. Thank you for watching. Is it just kinetics? See you.